In this video, I'm going to talk about persistent variables in MATLAB, in particular functions. If you recall, a function has its own workspace. The reason for that is when you call the function, the local workspace for that function stores values for the variables in memory, makes the computations specified in the function, and when the results are returned to the program that called the function, the local memory is then deleted. So you see, that's an important feature of the functions, is that the memory is purged after the calculations are made. If you performed all the calculations in a program, well, you could accumulate a lot of memory since all the results are in the current workspace. But the function alleviates that, so when you call the function, the memory is purged when the function returns the value to the program. So it's a pretty efficient memory management technique, and it's one of the main reasons why you can modularize programs in MATLAB and have a base program that calls functions, and the functions can be, pretty demanding computationally and consume a lot of memory, but it automatically deletes the memory when the results are passed back to the base function. There are times, however, that you may find it necessary to pass values of a particular variable from one function to another. So that's called persistent variables, and that allows the results from the local function to be retained or be persistent in memory and available for another function. So this example program includes two local functions and a live script. And if we take a look at the first function, and its a creative name, is called the function 1, and the input variable is just a number to keep track of how many times we call the function. Function does not return a value, so there's no output arguments. And it's a kind of a unique function here because we define a variable called count. We initialize it to 0 in the function number 1, and then we increment count by 1. So count is updated equal to count plus 1. And then it prints the following message to the program: the value of count, and then how many times we called the function. So in this case, this program has the local function workspace, and it will have two variables, each with a value, a corresponding value, the variable I and the variable count. Let's go ahead, and I'm going to call the function number 1 twice. The function number 1, and my input variable's 1. Function number 1, the input variable's 2, because I'm going to call it twice, right? So I'll run this section, and we see the its printed message is the value of count is 1 the first time we call this function. The second time we call this function, count is still 1. And that's reasonable because each time we call the function, count is initialized to 0 and then incremented by 1. So where does the persistence come into play? Well, let's create another function, and these are local functions. And this function is the function 2. And here, inside the function 2, we use the keyword persistent. So we declare count as a persistent variable within function number 2. We do some error checking, and we see is empty count. If count is empty, then we assign a value of count of 0 to count. And this would occur if perhaps we call function number 2 without incrementing or calling function number 1. So it's error checking, and you could experiment with that and see how it works, if you could trip up and throw an error or not, or catch it if it's not empty. So in either case, count is declared as a persistent variable. If it's empty, then it's initialized to 0. If it's not empty, it takes the current value of count in the assignment statement, increments it by a value of 1, and assigns it to the variable count. And then we print another message. The value of count is %d. Remember, d is for integer. And we call this function how many times. So let's see what happens now. We'll call function number 2 3 times. The first time, second time, and a third time. And we'll see what the printed message is for count. So I'm going to run this section. And now we can see the first time we call function number 1, function 2 the first time, the message says count is 1. So that means it started for 0, right? Because it was empty, we add 1 to it, so as a value of 1. That was the first time we called the function number 2. When we call function number 2 again, now the value of count is 2. If we call function number 2 a third time, the value of count is 3. So here's the persistent value. Count was 1 when we called the first value, called the function number 2 the first time. That value now is in the persistent memory. When we call the function number 2 again, count is incremented by 1, so 1 plus 1 is 2. We call it the third time, count is 2 plus 1 is 3. So each time we called the function, I was deleted from the local function workspace, but count was not. And it allowed it to be persistent for the next time, and every time thereafter we call function number 2. So function number 1, count, is not persistent, and it operates as expected. Each time we call the function, count is incremented by 1. The values return to the main program. Well, in this case, there's no return value, but the local function workspace is cleared out of memory. We call the function again, count is 0, and we add 1 to it, and it's incremented to 1. And then the local workspace memory is deleted and operates as normal as we expected. When we get to function number 2, by declaring the variable count as persistent, then when the function terminates, the value of count is stored in memory and is available the next time we call the function number 2. So that does the persistent variables, gives you an opportunity to retain values of variables outside of the local function workspace. So keep in mind, I want to make sure that I'm using local in two different places here, right? In the live script, since the function 1 and the function 2 are stored in a program, they are called local functions. But keep in mind also, function workspace is called the local workspace, the local function workspace. It's the memory allocation of the function. It's temporary. It's only valid while the function is running. In this case, it's very quick, right? We only have 3 lines of code in function 1, and we have 1, 2, 3, 4, 5, 6, 7 lines of code in function 2. In the first case, function 1, after the 3 lines of code are executed, the local workspace memory for the function 1 is deleted. When we run function number 2, the local workspace for function number 2 is deleted, except for the value count, since it is declared as a persistent variable. So you may have some need for that in programming. So MATLAB does afford you the opportunity to pass variables outside of the values of variables that you declare as persistent outside the local function workspace. Thank you.